we have seen in Newton's second law that force is the rate of change of momentum. And let's now put in some numbers to make this equation clearer. Right. Okay. Once again, let's start with our favorite object, little yellow ball. Okay. And suppose that we have a force pushing it. So this force pushes it. I don't know what the force is. Just let it be F. Okay, just let it be F for now. Now, suppose that this ball, okay, I'll just make it easy. I'll just say that this ball has a mass of 1 kilogram. Okay, that's its mass. That's its mass, which I'll call M. Okay, I'll call the mass M. And the ball at this point, at this point in time, okay, I'll make it easier. Let's say at first it is at rest. It's at rest. Now this force pushes at the ball, and suppose that the ball is sitting on a very, very smooth table. So no friction, just the only force is what we are pushing it with. So at first it's at rest. Now after the force pushes for some seconds, maybe 3 seconds. So say 3 seconds, the force pushes it. The ball moves, and it moves faster and faster. And when it reaches here, suppose that the velocity after 3 seconds is 6, right? Maybe 6 meters per second. Okay. The mass is still 1 kilogram, of course. So how would we calculate the change of momentum? Right. I'm just going to give some use some symbols to represent, say, v, the final velocity is 6. At rest means the initial velocity, which I'll call u, okay, is 0 meters per second. And then I'll have the time t. The time t is 3 seconds. Okay, so how do I calculate this rate of change of momentum? It's quite a few meanings involved down here. The rate, the change in the momentum. Okay, so it can be a little bit complicated if you're doing it for the first time, but we can work that out. So let's start from the beginning. Okay, so I'll start with what I'll call the initial momentum. That means in the beginning, right? From the start where I just started pushing it. In the beginning, the initial momentum, well, we know momentum is mass times velocity. So the mass is the 1 kilogram. Okay, 1 kilogram times, and the velocity at first is 0 meters per second. So it's times 0 meters per second. So the answer is just 0. Answer is just 0, but you mustn't forget the units is kilogram meters per second. 0 kilograms meter per second. So next, let me find the final momentum. Just do a ditto down here. Okay, my final momentum is equal to, right, the ball is still 1 kg. Alright, but this is moving faster. It's now at 6 meters per second after after 3 seconds. Okay. So now, therefore, my final momentum is 1 times 6, so which is 6 kilogram meter per second. That is my final momentum. What about the change? The change in momentum. Change in momentum was, well, the change in momentum means that we must take the final momentum and minus the initial momentum. So I would take 6 minus 0, 6 minus 0, and my answer is 6 kilogram meter per second. So that is the change in momentum. So fairly straightforward. All right, find the initial momentum, find the final momentum, subtract. Change in momentum. Now, so I've found the momentum, I've found the change. So let's now find the rate. Now, rate. What exactly is rate? What does it mean by rate? Rate often means, in physics anyway, often means how much something changes every second or every minute, right? Just change time rate of change, right? How much something changes per unit time. So the rate of change of the momentum, the rate of, okay, I'm going to use ditto again, the rates of change in momentum. So ditto change in momentum equals, so I want to know the change per second, right? Okay, the change per second. So what I would do is I would take the change, the 6 kilogram meter per second. So that's the change, that's the 6, and I would divide by the time taken, which is 3 seconds. So 3 divided by 3. And the answer is 6 over 3, which is 2. What about the units? I have, I know that the unit for 6 is kilogram meter per second. I know that the unit for 3 came from the time. So unit for 3 is second. So is this unit, the kilogram meter per second, divided by second. That means in the denominator, I gain another second. So therefore, the unit, the correct unit would be 2 kilogram meter per second squared. That's the rate of change of momentum. Now we come to the important bit here, where we now want to relate this to the force. Now, according to Newton's second law, the force is proportional to the rate of change of momentum. So not quite equal actually. Right? They're not the original Newton's second in Newton's original second law. Well, in his second law today as well, it says that force is proportional to the rate of change, not really equal. Now, but what we do today is that scientists choose the units of force, right, so that the force becomes equal to the rate of change of momentum. So it's just a choice of unit. If I choose a different unit, force being proportional, it would be some fixed number times the rate of change. So we are just going to take the fixed number to be 1, all right, which is what they do in SI units. So this is an SI unit thing, all right, image. Instead of in which we take this this constant of the proportion to be 1. Okay, so what this means is that in SI units, all right, we're just going to make things simple by equating force to the rate of change of momentum. So therefore, if the rate of change of momentum is 2 kilogram meter per second squared, we're just going to take that as a force. Okay, so that is the force, all right, according to this equation now. So this is the force. We already have a force. Okay, that's the force. So just to make that very clear, let me write this out here. This is the force, F-O-R-C-E. That's it. We have it already. Now, but the one thing is that if you look at the units, kilogram meter per second squared, that's quite a mouthful, right? Quite troublesome to go about carrying these units around. So instead of using this bunch of units all the time, you want to write force in order to save time, make things easy. Now, physicists invented a new unit called Newton. So N for Newton. So instead of carrying this bunch of kg meter per second squared around, we are just going to call this whole bunch of unit, we're just going to call it N. So N means the same as kg meter per second squared. And we say that in this example, the force is 2 newtons.